Welcome, and thank you for joining us today. It's a pleasure to have you all gathered for this roundtable on racial and discriminatory bias in generative AI, text, images, and the politics of representation. My name is Marianne Wainier, Vice President for Human Development, and I'm very happy to introduce this event that takes place within the framework of the International Week Against Racism. It's a moment that invites us not only to reflect on persistent inequalities, but also to examine how they have evolved and manifest in new contexts. These themes concern all of us. Today, these questions extend beyond society and the traditional sense and into the digital systems that increasingly shape how we see the world and each other. We chose this theme because generative AI is no longer a distant or abstract technology. It is already embedded in our daily lives, producing texts, images, and decisions that influence knowledge, perception, and opportunity. While often presented as neutral and objective, these systems are trained on existing data and therefore reflect and sometimes amplify the biases present in our societies, including racial stereotypes and forms of discrimination. Addressing these issues requires more than technical expertise. It calls for dialogue across disciplines and perspectives, ethical, legal, technical, and societal. This is precisely what we aim to foster today. We are delighted to welcome our distinguished speakers who will help us unpack these complex questions and open a critical conversation together. Professor Andrea Cavallaro, thank you. You lead the Laboratory of Multimodal Intelligent Systems at EPFL. Dr. Anna Sotnikova, Neutral Language Processing Lab. Estelle Panatier, Senior Policy Manager, Algorithm Watch. And the moderation will be led by Melissa Ankizi, Head of Communication AI at our AI Center at EPFL. Thank you for being here and participating, and we hope that the discussion will be both insightful and thought-provoking for all. I now pass to Andrea that will do an introduction on how Gen AI is developed and where bias might occur. Thank you very much, and enjoy the afternoon.
Thank you, Marianne. Good afternoon, and thank you for choosing to spend your time with us this afternoon. I'm very pleased to see that so many of you decided to participate in this dialogue that, as Marianne just mentioned, it's very important today, especially when we have technology that is so powerful and in the hands of everyone. What I'd like to cover today is not only the potential pitfall of the technology, but also the agency we have to design that technology in a way that serves us. We will need to understand how the technology works, and we will need to understand what we want from this technology. I chose the title to put in evidence our active management of AI, and in particular of its bias. We have a very short period of time to cover AI and bias, and I do hope that by the end of this conversation, you will have your own framework to see AI and bias, and I'm looking forward to your observation and comments during the question and answer session with the panel. Now, what can we do in 10 minutes to have a sense of what AI is, what bias is, and how bias enters AI, and what we can do about that? So what I'm interested in is what we, as researchers, as citizens, can do in order to ensure that this extremely powerful technology is at the service of societies and individuals. I teach a course here at EPFL across 20 different master programs. So I have students from life sciences, NeuroX, informatics, electronic engineering, robotics. And one of the main goals I put to myself when I designed this course a couple of years ago, was not only to enable students to understand how to develop extremely powerful technology, but also to ask themselves questions before developing their technologies. And at the beginning, I was a bit skeptical in designing that in a very technical school. But the reaction I had from students, actually the first year I taught the course in exactly this room, and at the beginning I was, I don't know how they will react when I say, oh, we need to ask ourselves questions before developing technology. In an environment where the technology is often move fast and break things, I was coming here and telling young students, hey, it's not because you can do it that you should do it. And their response was amazing. And part of the course has got a mini project in a group, so where students have to dialogue among themselves, and they have to develop technology to help design safer online spaces. So they are detecting harmful content, hate speech, in a variety of format, whether it's text, videos, images, memes, or audio. And they are extraordinary in the way they put their creativity in place in this type of problem. And if you are interested, in the last Wednesday, in the morning of the last Wednesday of May, the month of May, we will have an open poster session where they will present their work and they will showcase what they have learned during the entire semester. But back to us. So we have 3 points I would like to cover today. The first one is to give my definition of bias in the context of this conversation. There are many definitions of bias. I will provide you the one I think will help us cover the other 3 points. What is the origin of AI bias? If we know what the origin is, we might be able to do something about that. And I'd like to finish with a number of activities we are doing in Switzerland, in my lab, to try and design AI systems in a way that they serve all of us and not just some privileged fews. So let's start with the definition of bias. In the context of this presentation, bias is a systematic prejudice, meaning the system results will be skewed towards a particular group of people, a perspective, or an outcome. So we have a system that systematically provides an output that is distorted. Why? Well, now you're listening to me, you're not hearing directly my voice. My voice is emitted by my mouth. It's an analog signal that is compressing and rarefacting air. It gets captured by the microphones. It gets digitized. And we know at what frequency we have to digitize that signal because we know the maths about that. So when the voice gets amplified digitally and gets to your ears, you're not losing anything of what I'm saying. AI is very different. We don't have a mathematical formula that defines exactly how the system should behave. We decide a certain architecture. We decide to have a certain data set. And then we hope, I repeat, we hope that the good specifications from the data set get transferred from the data to the architecture we have chosen. Wow. That's where bias comes from. Now, we don't have the control we have for traditional technology, where we did the math, so we know the boundaries, we know the bounds, and we're in control of that. Examples of bias in the medical domain. This was from 2021. Move fast and break things, be the first to market. You create a medical device, and that medical device discriminates between different types of people. Not only medical devices looking at cancer, but also medical devices looking at the level of oxygen in your body. Systematic discrimination of group of people. That's unacceptable. Luckily, when AI works with experts, they have demonstrated at the end of last year that doesn't matter the level of training of a doctor, it is possible to improve by 5 to 6 percentage points the performance of a doctor in diagnosing cancer. That's a very positive note. So if we want to let the system go alone without having the control of the maths, then we have discrimination. However, when we have a human in the loop, we are capable of improving the performance of the very same human. Why is the discrimination of the system working alone happening? Well, this is AI. Let's have the simplest possible representation. This is an object with 1 trillion parameters, 1.8 trillion parameters. It's a lot of numbers. And those numbers get their value through a training process coming from the data that someone has chosen to use. Then, the characteristics that are embedded into those data are passing on to the system. We are interrogating that system with our own prompts, and we get an answer. Our own prompt can be, let's generate an image of a certain environment, and we get an image. Oh, I got this symptom. What could that be? We're using it every day. But we don't know that because of the bias, we have a little devil there that adds some information, which is the bias, that is distorting the output. Right? So this is one possible conceptualization you can use to see bias. Bias, you have an adversary that is providing information to the system so that the output is incorrect, is deformed, is distorted, is giving preference to a group of individuals compared to others. And of course, when this is used in healthcare, in finance, in selection of personnel, human resources, it can create discrimination and therefore harm. So we are interested in understanding how we can avoid that, or better, how we can mitigate that. Because unfortunately, bias is part of our lives. We are biased. And the important element of bias is to knowing our biases so that we can compensate for those. And a similar observation can be made for systems. Systems are biased. We want to minimize the amount of bias they express when they're used. And for the rest, we want to know what biases they have. So when we have a human in the loop, we can exploit, we can use for good those systems. So where is actually the bias coming from? Well, so far, we talked about data. But in reality, there are other steps of the pipeline that generates artificial intelligence systems that are influencing bias. One is training, which is a technical term to say the system is giving a certain value to that 1 trillion parameters. We have read book to learn. The modern AI systems have read the internet. That is the process of training. And then we deploy the systems. They generate some results. And even if those results are biased, we can do something about that. So in terms of data, the problem associated with bias is that the data are not diverse enough. If we have data representing only Switzerland and we apply the system in Norway, well, we will have some surprises. Maybe we are using a data set of historical events, and the data set itself is biased. If we are feeding that data set to the system, well, that system will learn that bias. So in order to mitigate, to limit the bias with data, we need to verify the data. We need to spend time understanding what data we are feeding the system. Because remember, we are hoping that the data we chose are transferring to the system the properties we want the system to have. And therefore, we need to spend quite a lot of time to curate those data, to select those data, to check if there are imbalances in those data. Training. Well, the optimization process is an averaging process. So if we have a nice, diverse distribution of preferences, and then we optimize those preferences, we will get an average. So unless we include in the training objective fairness, the system is not meant to if we're using traditional optimization tools. And likewise, AI is optimizing for a certain objective. If we are not good as designer in defining those objectives, the 1 trillion parameters will learn something we are not expecting them to learn. For example, if we are looking at historical data of debt, even if we control for racial information, maybe the zip code, the postal code, will provide that information. We are asking the system to learn, and the system will not learn something we believe is good. We learn something that allows the system to maximize the objective of the training. So as designer of the systems, we have the responsibility to reflect on this, to verify the data, and to have systems that are capable of explaining why a certain decision was made. Finally, the results. Given any system, it's important that the human using that system is capable of being aware of the type of output is generated so that they can interpret those results. Human in the loop, as we saw earlier, is a way in which we can increase the performance of a human in their task. But of course, that human shouldn't get to a point where say, oh, the system tells me that. I accept the response. I accept what the system said. That's called an automation bias. So in this case, we have to be able to monitor the system and to monitor the human that is interacting with the system. So we can summarize this observation into 2 concepts. The first is the concept of transparency. The system must be transparent. The data set used for training must be transparent so that we can audit how the system works and how the system was trained. And then we need governance of AI through oversight. We have a number of non-governmental organizations, civil society, who are helping monitor what's going on. And based on the errors, on the discriminations that are detected, we can then improve the entire cycle. So, based on this formalization of the problem, what can we do? Or what have we done? Well, if we look at Switzerland, in September last year, there was the announcement of a world first. Apertus is a large language model, a local ChatGPT that was trained with all the properties, all the good properties we just mentioned. So these are colleagues of mine here at EPFL, at ETH Zurich, in other universities in Switzerland, together with the Supercomputing Center in Lugano. And they tick the boxes in all of the elements we mentioned before. It's the first very large-scale Swiss-trained model that was trained on over 1,000 languages. It's open in the sense that the dataset is known, the dataset was curated, the recipe for training is known, the weights, all the data is open. That's a way to have a transparent system that can be audited, and this system can be used for research and for commerce. And this is a contribution of Switzerland, and it was the first case of such a large case of training an LLM that was made available to the world. In the first presentation, Marianne was mentioning about collaborations, and here I would like to show you a collaboration we're having in my lab with other universities in Europe. This is a European project with 17 PhD students funded to try and align AI systems to human values and preferences. I'm collaborating with psychologists and social scientists in Munich, with philosophers in Eindhoven, and we have here in the Doctoral School of Electronic Engineering 2 PhD students who are working on transferring what we can learn from social scientists and cognitive psychologists into a learning system. So we are trying to identify user preferences, to identify values of vulnerable people, in this case our children, and then we have a group of philosophers trying to conceptualize how these pieces of information can be encoded in a system that then learns and serves a human. And here we have 2 PhD students, Zen and Yun Cheng, working on how to embody the knowledge of social scientists, philosophers, and cognitive scientists into systems we will be able to use. And the psychologist, the social scientist, and the philosopher gotcha, another two that now I'm forgetting. Help. No help. Okay. Will be coming here for a period of stay here in Lausanne. In addition to these students, we have another group of students sitting over there. It's a handful of students from the lab. It's the Laboratory for Multimodal Intelligent Systems, where we work on safety and alignment, robustness and interpretability. We have, and I'm seeing them, so the name is easy to remember, Alina working on interpretability. She's asking, what if? So what if we change one variable to the data? What are the results? Olena is working on how to characterize the preferences of humans, how to understand what are the relationship between personal norms and social norms, and how to use that to understand how to best serve a human. Mirko is the psychologist in the group, and he's working on how to help us have safer LLMs, so that the interaction with the LLMs doesn't deteriorate our mental wellness. And Lorenzo is working on interpretability, trying to understand causality in between different parts of the pipeline. And if you're interested in understanding more about what they are working on, they will be around during the apéro, and I'm encouraging you to have a chat with them. Thank you very much for your attention, and I'm looking forward to the panel and to your question. Thank you.
Thank you, Andrea. I will ask you to stay with me here and join me. And I would like also Estelle Panatier and Anna Sotnikova to join us for this part. There was a lot in your presentation, so there's a lot to unpack, a lot of food for thoughts. Please keep your questions for now, because I have a lot of questions I want to go through first. But I will, of course, encourage you to ask some questions a little bit later on in the panel. And I want to start with you, Estelle, because you're part of Algorithm Watch. And so obviously the question of discrimination and algorithmic bias is at the heart of what you do. Can you maybe tell us a little bit what Algorithm Watch does?
Yes, sure. Thank you for the invitation first. Algorithm Watch is a non-profit organization based in Zurich and in Berlin too. And we are like a human rights organization focusing on the impact of algorithms and AI on fundamental rights, on society and democracy. We work so that those technology can really benefit to everyone and not make damages. And our approach is what we call evidence-based advocacy. So we first do like investigation work. It can be like journalistic work or also tech research or scientific collaboration. And on the basis of those evidences, then we elaborate our policy recommendation that we bring to the society, but also to decision makers. So that's the kind of framework. And of course, working on the impact of fundamental rights, we also work on the question of discrimination through AI.
Mm-hmm. And we'll come back to the process you go through, but where do you see for now the most harmful cases in Switzerland?
I think when we speak about AI and discrimination, where we see the main problems, it's really when those systems are used for decision making. It can be, if we speak about generative AI as we do today, when we use AI system to generate content that will influence like decision we are taking about people, that can harm people if they are discriminated through those decisions. But it's also when the system are used to make recommendation or to make decision, that's really where like the biggest issue from a fundamental right also perspective is to find. And I think there we can also see that it's often people who are already or groups that are already vulnerable and also discriminated that are more subjected to that, and that we see the main risk also in domains where we see the biggest power asymmetries, like if you talk about like migration or work, where you have like a big imbalance between the people who are applying for a job and the people deciding for the jobs, or in medicine, like everywhere where you have like big power asymmetries, that's also where you have the biggest risk of discrimination.
I want to ask a question to all of you on discrimination. Obviously, it's not a new topic, but do you think that the nature of discrimination and the speed, even the scale of it, has changed with AI systems gaining more and more traction every day? I don't know who wants to answer first. Maybe Anna? I think it's already turned on.
Oh, okay. Great. I think with AI, all our biases and stereotypes are being not only amplified, but also distorted and maybe sometimes obscured. So we're getting the worst case when we don't know how exactly they will be changed. Either they're getting bigger or they're getting also distorted a little bit. So this is from what I've observed so far.
So you mean obscured in the sense of we don't necessarily realize there is a bias at play, correct?
Yes, because AI in general, like if we look at the most powerful models, and if the model is poorly performant, it's not that an issue because we typically clearly see what are the downsides of the generations, but when the model is well performing, that's more dangerous because it could look neutral, reasonable, convincing, and there still could be bias.
And actually, Andrea, I love the slide you had because you had AI represented as just a black square, like it's a black box, like in planes, right? We don't really know sometimes what goes in, apart from a purchase, but we'll come back to it later. But so I heard a lot of things, like presumably, and you mentioned it, the whole humanity has been, or all the texts that humanity has written has been like fed to the black box, but is that correct? Because we also know sometimes that they are far more English dominant, so does that mean that we don't really know what's been fed to the black box?
Right, so luckily in the case of Apertus, we know that's well documented and public, but for the commercial tools that we're using every day, that's a commercial secret, and we don't know exactly not only the data that went into that, but also how that data went into the machine, and how you pass the data to the machine determines the final values of the parameters. Getting back to the black box, it was very dark, but it was not really black on purpose, that square. But yes, it was to evoke the concept of black box. The interesting thing is that none of the systems per se are black boxes. We can measure the value of all the trillion parameters that are there. But even if we can measure the value, we don't know what they are doing. In one of the works we had done in the lab, with some of the models, just put into 0, 4 to 5 of these many billion parameters was creating a completely gibberish output of the system, which means that these systems are very brittle. What the community is trying to do is to understand how either you can find some circuits or algorithms within those parameters, which is a very difficult task for very large models, or at least being able to have guardrails around the systems. And the
guardrails that are decided by a human being, correct?
Yes, so you let the system works as it works, but either at the beginning, so you add your prompt, but after your prompt, there is what is called a system prompt. That somehow, like for example, if you add, show me an image of a CEO, maybe there is a system prompt that says, if the user says CEO, be diverse in the way you generate the output. And then there are some guardrails at the output, where you have ways in which you check how the system produces the final output of the system.
But aren't these safety guardrails kind of like a cosmetic fix in a way? Because it's like, oh no, you have to make sure that you generate an image of a female CEO and also make sure she's a black female CEO, just to not offend anyone. Like, is it a little bit like of a gimmick?
It's not only a cosmetic thing, it's also an additional layer of bias. Because you will have the designers having the power to decide what is a desirable output. Right? So it's an additional layer of potential discrimination that if the designers of these systems are not aware or are not signaling that, might generate even more discrimination.
So really it's very hard, what you're saying is that it's very hard even just with the data to predict the outcome, because I mean, if we think about the images, there's a lot of different input that have been in there, and like surely we have pictures of all type of CEOs being represented, hopefully, but this is really then down to whoever decides to put in place these safety guardrails, right? And maybe a follow-up question for Anna, because obviously your expertise is more on the text-based generative AI, but when we talk about language, we know that culture is inherent to language. And would you say that then models that are mostly trained in English, then they replicate the bias of English native nations, mostly maybe American models, for example?
Yes, it's true, but we're also getting more and more multilingual models. And for example, again, I'll mention Apertus, because 40% of its training data is non-English, which is supposed to help improve situation. But regarding the like short note back to the data that model trained is on, so it's trained on easily accessible data. We don't know which data exactly, but technically, it was filtered, so it was filtered for the data quality, maybe some technical aspects that the company cared about, but then it was still easily accessible data. So it represents the population that is the most active on the internet, which is presumably frequently English one. So when we talk about the culture, the model represents to some extent English culture, but for example, in one of our work, we studied how stereotypes leak through the languages in multilingual models. So we compared human stereotypes in those languages, and then we compared what's happening in the model. And we noticed that actually in multilingual models, stereotypes leak from across languages. So they change. They no longer represent stereotypes, let's say, of people who speak Chinese from China, but they could be slightly affected by stereotypes from other regions.
Do you have examples, more concrete examples?
Yeah, for example, people of homosexual orientation in Russian language and in Chinese language were perceived more negatively than in English across humans. But when we tested the model, it had more positive perception that corresponded to English language. So it was a positive case of positive stereotype leakage towards Russian and Chinese. We also observed negative stereotypes leakages, so it really depends on the cases. So, and it kind of happens bidirectionally, not only from English to other languages, but across languages.
So effectively, if you have more than one language, you kind of ensure that there's a little bit more nuanced views of the world in a way.
I think it means that you really don't know what's happening, and it means that these systems shouldn't be used to, let's say, replicate human annotators if you want to study some questions related to culture. Because basically we don't know which culture they exactly represent. It's kind of a little bit distorted, and we don't know in which way exactly. Maybe Andrea has something to add.
So I think it comes back to what Melissa was saying in terms of having these patches. So one way to control the way a system produces their results is to have the system undergo what is called reinforcement learning from human feedback, meaning refining the values of that 1 trillion parameters through feedback given by humans. But who are those humans? Who chooses those humans?
Right.
And how that human feedback is then used to modify the value of the parameters.
Right.
So all these are choices that if are not done properly, they will increase potential discrimination, increase potential bias, and therefore render the system perhaps apparently innocuous, but in reality presenting only one worldview or favoring only one group of people.
But that also means that as a user, when I'm feedbacking the content that is being generated, I like this picture, I like this video, I'm downloading it, or no, I'm going back and reprompting again because I'm not satisfied. I myself am kind of injecting also my own bias, potentially. So with the designer developing the system and then the safeguards being put in place and the annotators also putting their own thing, like, aren't we sometimes swimming against the current in a way? Because it's like a lot of people who can have an influence, right?
That's a nice visualization of this problem. And in reality, yes, we are, with the interaction we're having with the system, we are feeding the system with information about our choices. And those choices get transformed into a personalization of the system. So if you, I don't know if you're using Claude or ChatGPT or Gemini, ask the tool, what do you know about me? And you will see quite a lot of information, right? And that is the information that the system uses to please you.
I see. Anna, you wanted to...
Yeah, I wanted to add that that's why human-in-the-loop evaluation and overall human-in-the-loop design is so rare, because it is expensive. Because to cover all possible social groups, it is hard and expensive to do. And that's why it's still developing and it's not frequently used.
I see. Estelle, I had a follow-up question, unless, of course, please, if you want to comment on that, but it seems incredibly difficult to know what's going on within the system, so we can also assume that some people don't even know they're being discriminated by an algorithm, actually. So is that also part of the issue? Are you looking into how these decision-making systems are working in the first place?
Yeah, I think we have different issues. If we look more at generative AI, as you were speaking before, it's also the whole impact on the information ecosystem, because at the moment when we try to get informed, we are more and more doing it also through AI system, like if you have AI overviews on Google, when you do a Google search, or if you go make research through ChatGPT or other tools. And of course, those stereotypical views will then also have an impact on our opinion, because we are always confronted to that, or to those bias. And if we take more the other aspect, which is the decision making, which is maybe probably other system, generative AI sometimes, but can be also other algorithms and AI system. There it's often the problem that people don't know that they are actually that a decision is taken by a system, because you are not informed about that. So it's really a black box, not only how the system works, but also just where the system is used. We see that we are in a big automation process, but without like the transparency around it. So if you don't know where and for what the system is used, you cannot do anything. You cannot know you might be discriminated. And then if you want to show a discrimination from a system, it's very hard, because you don't have the access to the system. It needs a lot of resources, and also because the legal definition of discrimination is also something very narrow. So that makes it all the topic very, very, very complicated, I would say, and that's also why we are advocating actually for a change in governance, also like not only solutions at the technical level, but also at the governance level to protect us better against discrimination through AI and algorithms.
But when you say the definition of discrimination is narrow, what do you mean exactly? Does it mean some groups are being excluded and therefore it's not considered discrimination, or?
Yes, it has to do with the group, but it's also because you on the way you have to prove the prejudice, like that one individual person is really affected by a prejudice, which is with AI quite hard also to do. So there are many aspects that makes it actually quite narrow. If you look at also the protection against discrimination in Switzerland, it's it almost does not apply to private actors, which means that if private actors use AI system that discriminate, you you cannot do anything or like legally against them. So that asks a lot of questions. It's also problems we already have, like in the when you are discriminated by a human, but it's even getting stronger and bigger with AI systems.
And we'll come back a little bit later to the legal framework and the regulations. But I had still some questions around the bias and the technical aspects, I would say. And Andrea, you mentioned your class on your course on the detection of hate speech, and I think it's also a form of discrimination, obviously. And sometimes, I guess, it might be easier because it's very explicit, so you can read it that, yes, this is clearly discriminating a group, but sometimes it's a bit more implicit, so you have to get the context. And is that possible technically to train the machine to understand the context?
That's actually where those extremely powerful machines, models, can help. Because they have been trained on the cultural production of humans on the internet, they have seen and encoded, compressed in the 1 trillion parameters, what has been written and digitized. So all the nuances you will see in movies, in newspapers, in books, have been somehow encoded, compressed into this models. And what we saw with the work led by Alina, who's sitting here, and a group of students from the course, is that today, with these very powerful models, instead of having very complicated architecture where we are looking at emotion and intention and subtlety, we just use one part of this very powerful model, which is called the encoders. And because the encoder has got information about what has been published in the internet, they can, if they're properly refined, and this is a technical term, they can help finding these nuances in hate speech. And we have demonstrated with this group of students that it's possible to design a hate speech detector for subtle hate speech for text that works extremely well across different data sets, which is a very good property for this type of elements. So this is for text. And then in other work led by Olena, who's also in here, we looked at the similar problem in video. Where you have the audio channel, you have the video frames, you have maybe text overlaid on video. And each of these modality will be harmless. But the juxtaposition, the contradiction between modalities is the vector of hate speech. And by appropriately cross-checking between modalities, we develop a pipeline that is capable of detecting hate speech in video when hate speech is not explicit in any of the modalities. So in this case, these models are helping detecting what humans might decide to spread in terms of harmful content on the internet.
And so are the same system that potentially spread discriminative content, misinformation, I mean, we see it also with the deepfake, could there be also the same to kind of target it, identify it, but also enforce maybe more inclusive worldviews?
I don't know if it's the same systems, but what is sure, it's the technology itself is not neutral. It depends what the objective we are following with them. And at the moment, we see a lot of ongoing discussion on the use of AI for efficiency, for saving, for reducing costs, etc. And it's not so much of a topic of reducing discrimination or increasing equality in society. But we could actually also decide we use those technology for that. But then we really have to design them also for that and for the common good, and not just like hope that if we use a system for better efficiency, then it will also reduce discrimination, because that's not happening. So I think it's more about like setting like more about the framework, like the decision we take when we are using the AI system, and the question we should actually ask ourselves is, which AI do we actually want, because they are not all the same.
Yeah, and indeed this is the lack of incentive to create AI that is supporting this type of objectives. But luckily there is some governance out there that can help. ISO here in Geneva, the International Standardization Organization, already provided a standard for the management of AI systems. I think it's called 40/2001, and it prescribes the steps that are necessary for a company to have a certification of their AI systems in a way that respects the conditions that at the moment are required. Then there is the AI Act, which is another important piece of legislation that mandates that systems using AI that are considered to be high risk are undergoing a certain level of scrutiny in terms of auditing, in terms of registering the system in a certain registry of European technology, and also they are required to monitor the behavior of the system over time. Because something we haven't yet covered is that those systems are trained, then they are deployed in the real world, and they might change their performance in the real world. And that's something that is rather new in terms of technology.
Right.
We are not used to have a system that we deploy, and then based on the interaction these systems has got with the environment, its performance will change.
So it's adapting itself to its environment.
Yes.
Yeah.
And therefore, this monitoring has to be continuous, and the reporting of any errors, of any major problems has to be very rapid in order for the regulators and the overseers to be able to intervene and to understand what is the landscape of the use of this very powerful technology.
So I guess it's also very much field or like context dependent. Do you think, Estelle, there are fields where we should really not use AI to support decision making because there's too much risk of a discrimination to occur?
I think there are very sensitive places where we, regarding the use of algorithms, that is not only a question of bias, but can be also a question of mass surveillance. For example, if we speak about facial recognition in public, in the public spaces, etc., where we also know there are some actually some bias and discrimination issues. But I think the most important is not it's probably more like how do we use it and what kind of framework do we have also to have like a proper use of it, because we spoke a lot about the problems regarding the data, but there is also a lot that is related to the way a system is used, for example, because we have people over-trusting the recommendation of a system, and then just like even if a system is like there to make recommendation, at the end it takes decision because you have a human in the loop, but the human tends to overtrust the system. So to overcome all of those things, we really have a need of like finding a way, like a better way of using those systems. It goes also, we spoke before about like transparency. We need to know where the system are used, but also how they were trained, etc. So I think it's not like one solution, but like many different aspects that we need to take into account into like governance for a responsible use of AI.
When talking about maybe fair AI in a very broad sense of the word, one thing we had mentioned a little bit when we discussed on, to prepare for this panel, but there could be this provocative argument that AI is not necessarily biased or discriminating, but it's actually showing a representation of the world, right? So if, again, to go back to the CEO example, if there are more pictures of white men CEO, well, that's just a representation of the reality. And what would be the right balance at the end? Do we want to have a status quo or like a picture of what's the current situation, or do we also want to enforce a little bit more of you know, an evolution and an inclusivity in the systems?
Just to correct on this, regarding the CEO image in general, so there was a study when they trained a system with 60% of images women cooking and 40% of images men cooking. The resulting system produced 80% of images of women cooking. Mm-hmm. So the bias in the model is amplified. So your reality could be 60% of images male CEOs. The model will give you 80% of images. Mm-hmm. So that's...
So it's not even a reflection of reality, it's just amplifying.
It's like amplification, distortion. Mm-hmm. Again, what should we do? I guess in some cases, we just put safeguards and demand certain diversity in the outputs, especially when the model usage is known. And for example, in large models, we do human alignment. So in post-training phase, we try to align with certain human values. Then it's obviously a question how we design those, how we make our design choices. And how the models should reflect cultures of other societies, of other social groups, of other regions. I think there is no clear answer yet what models should do, but at least we should be aware of what model represents. And if it's, let's say, highly skewed towards Western biases or not. Maybe you have
absolutely. I think that's the right way to characterize this. It's difficult at the moment to conceptualize how we want the systems to behave. Like if you type in your favorite Gen AI tool, a picture of an exotic wedding. Mm-hmm. What does it mean? And for whom? Yeah. I had an experience when I was a teenager, and I had my cousin from Australia who came and visited in the Dolomites. We went showing him around, and at a certain point said, "Stop the car. I want to take a picture." I was looking around, I didn't see anything particular around. He wanted to take a picture with the road sign of the crossing of cows. Mm-hmm. Because for him was unusual. Like when we go to Australia, we take a picture of the kangaroo crossing, right? So it depends for whom we are designing. Yeah. Awareness, as was just said, is extremely important. We have to recognize diversity of lived experiences, diversities of preferences, and the work we are doing with Julia, Gotche, and Zineb is exactly that of understanding what certain communities prefer, or what are the values of certain societies, plural, so that we can embed those in design of the learning systems. Then how it is deployed, it's, I think, still something that we have to properly understand. This is a technology that is very young, very recent, extremely powerful. We didn't have anything similar in the past. I call these tools cultural artifacts, that they are somehow compressing the culture that had been expressed primarily by rich countries for which we have digitalization for the last 40 years. Right. How do we use them to serve groups of people in a way that is appropriate, is desirable, is good, is still a very interesting question. It is important that people are aware of the biases that these systems carry with themselves.
Anna, you wanted to add something?
Just a quick note that right now there is a lot of movement towards personalization, personalized AI systems. Right, so that we're not talking about a single AI system that will serve everyone, but more or less we're talking about more personalized approaches. Whatever that could mean. If we're talking about education, maybe it's personalized for the students specifically. If we're talking about cultures, region, personalized towards those regions, for example.
Estelle?
Yeah, I think also joining on the fact that probably we need more personalized or also context adapted models and systems, and that also goes maybe in the way of also not having only the big models, but also the smaller models that you can have like more targeted for the use you have, which also resolves other problems like regarding like durability or the cost, energy cost, etc., which is also an issue. So I think we are in that big trend of having the bigger model that can do everything, and wow, you can do everything with it. But I'm not sure that that's going to last. I think there is also a lot to do, and very interesting technology development in smaller models.
Because you mentioned it in your presentation with the example of the racial discrimination with the skin disease models, or like identifying diseases model, but effectively I think we do need the model to recognize, oh, this is a darker skin, therefore the disease might show differently, right, on the photo. So you do need this identification, I would say.
You could have a step beforehand to detecting the type of object or skin it's being identified, and then have an optimized model for that type of skin. It's a very common strategy to have what is called mixture of experts. Each of those tools will provide their prediction, and then you will change the weight of how you weight each of this prediction based on having observed what type of surface skin object you're looking at. So it's true that one of the problems with bias and discrimination is probably coming by the fact that there is a competition of creating general purpose AI. Once we will start designing primarily tools for specific applications, we might go back to what we know in terms of checking the safety and security of toys, of objects that provide us with the recommendation that are very, very specialized. We will have the advantage that we will have smaller models specialized. They will probably require less energy to train and to deploy, and so we might have multiple advantages with that type of choice.
And that might be one solution, right? Like you mentioned before, having more like context-based or situation-based models that are tuned to support a specific context. But I do want to address that kind of like uncomfortable question, because when we talk about racial discrimination, we know that for years it's been always difficult with people with darker skin to be identified or to be targeted. As a matter of fact, if we look at some facial recognition systems, why is that? Do we not have enough data to train models on different skin colors, or what? Why was there this issue, and where are we with that nowadays? Sorry, it's really uncomfortable, but
no, I think
we need to talk about this.
It's a very important topic to cover. There have been a number of cases where individuals were thought to be another individual who was wanted. Because the system didn't have the resolution of discriminating different human beings, because of the way the system was trained. If you have fewer images of people with darker skin tones, of course the system will perform less well. If you're not making a decision that you have a subject for which the data set used for training was unbalanced, and you haven't controlled for that at the time of training, then you will have to control for that at the time of deployment. So there is a responsibility for people who deploy the system to be aware of the biases and to ensure that the system will be capable of fit the purpose for which the system was deployed.
I have also a small comment on this, maybe not exactly related to the images, but when we were starting our work on bias evaluation, typically you go to crowdsourcing platforms and ask people whether, for example, they consider this instance biased. But the problem is that this gives you a snapshot of people who work at these crowdsourcing platforms. And this largely...
It's not representative.
Exactly. It represents a certain subset of people, right? We are not getting people with high, typically because we ask for demographics, we're not getting people with higher education, higher salaries, or alternatively, we're not getting people of certain age because they might not be familiar with such platforms, et cetera, So it kind of gives you very restricted, not very restricted, but reasonably restricted set of people who did the annotation. And the question, how would we improve that? Because we also need to have, we need to run the research, I guess so people will understand me now, but what do we do about that? And it's a difficult process, but basically our, let's say, bias prediction is shaped in a way by those people as well. And at least we have to keep that in mind, even if there are no quick workarounds.
But maybe this is my ignorance, but obviously we heard a few scandals around the annotation being done in certain countries of the world, and often populations that are effectively discriminated by these systems. But is that helping? I don't know, how is that playing a role in the data set and the bias that is? Because presumably if we take a population, I don't know, we heard of examples in Nigeria or Kenya where people are doing the annotation, so effectively are they supporting like reducing the gap in the discrimination when they're annotating the content, or is that not really how it's being supporting the systems? And that's just really, I don't know how it works, so.
So there are different angles here. So luckily, or not, those systems don't need per se labels to be trained. The way a large language model is based on text is usually trained is by taking a text, covering some words, and checking how well that system is able to predict the hidden words. And since we hide them automatically, we know what the label is. So there is no necessarily human annotation. But when we go to multimodal systems, for example, we will have pictures next to text, and the text next to the picture might be used to annotate that picture.
I see.
And it's where we will have a lot of bias. In terms of groups of individuals that are hired to label content, a lot of this job is about looking at potentially harmful content, and therefore there is an additional layer of harm on people who have to spend a substantial amount of time checking on content and labeling whether it's actually harmful or not, and having to observe that for a long period of time, and that's certainly a form of harm. And there is the recent news of a wearable device that has collected a certain amount of videos of intimate nature, of violence that people were exposed to in order to understand how to improve that system. So these are not only biases that a specific type of workers might introduce with their lived experience in the labeling, but also harms to the workers themselves.
Oh, absolutely, yeah. Yeah, of course.
Yeah, I wanted also to react with the lack of diversity of the people developing also the technology, which also don't help because you have only like certain ways of looking at the world, and you lack the diversity, not only in the data but also in the people designing the system. And we also had it in introduction the problematic of like indirect discrimination or proxy, and I think there it also plays a lot of like a big role. Like I had an example also of AI in recruiting, where application where people had lived where people had done their studies abroad were graded as less good application as others, and that has all. It also says something on the people who are applying and creates some kind of discrimination. So it's very pervasive, and it also makes it really hard also to go against it.
So I kind of want to not finish on a depressing note, so maybe we try to discuss a little bit what kind of solution potentially there could be. So Estelle, maybe with you, what would be one of the solution if you feel you're being discriminated by a decision-making algorithm in the case of, like you just mentioned, recruitment, for instance?
Well, I think we need more evidences, and on an individual level, we provide a form on our website where people can report cases where they think that or have encountered some discrimination. So please check our website for that. Or here,
we have
even
it
better.
Here as well, actually.
And I think it's also very important to say we will not be able to solve that on an individual level. We need to work on the technical level, as we said, but we also need to work on the political level. There are really like several levels of action. We did also a project on discrimination in recruiting, where we did like toolkits for software developers, for HR professionals, for decision makers. I think it shows that, yeah, there is a shared responsibility really at every level.
Mm-hmm. And we put the QR code for the reporting page, so feel free to take it, but also have a look at the website of Algorithm Watch, of course. And for our tech people, what technically can the AI system designers do to potentially overcome some of their own bias?
I think there are different steps when we try to overcome biases, starting from the data collection, going into pre-training, post-training. All these phases, they involve steps. But I think another important step is to measure bias. If you don't measure it, it doesn't exist. So we need to measure it, and we need to talk about it, and we need to make people aware. Maybe we cannot fix it, but at least we can make we can be vocal about biases. And also on the user side, users should be questioning model outputs and not taking it as the ground truth. I think that part is important.
Mm-hmm. Andrea, do you want to add something?
I think this questioning part is fundamental. Mm-hmm. And what we have seen tonight is that we can't consider these systems as just systems. They are social, technical systems. They are working within a certain environment with human beings. So we probably have to go beyond the idea of user and technology, and to conceptualize the pair, user, actually actor, and technology. It's fantastic to see so many people having chosen to spend some time in here. That's already a demonstration that there is interest, and having the ability to rely on those systems, but to be critical not only on the output of those systems, but also on the inputs we provide. Mm-hmm. So if we are very prescriptive in what we ask those systems to do, we will ourselves be able to reduce the bias that those systems will produce.
Thank you. And I would like to open the floor now to questions. I think we have a little cube, which is a microphone, so you can actually throw it and catch it without being scared of breaking it. So if you have a question, I think there's a gentleman with glasses in the front down there. I think you can just throw it, Natasha, don't be scared. Well done.
Can you hear me? Yeah.
Yes.
So I wanted to ask if you could elaborate a bit more about the human in the loop, because I feel that some people think that with a human in the loop we're safe and that fixes everything, but not all cases are very obvious. I think we would expect a sane person to, for example, not approve an attack on girls' school, but still it happens. But I'll do a couple of examples just to explain where I'm going. One, let's suppose we have a system that flags possible people that should be checked for an audit for tax declaration. And someone could say, oh, look, we have very few false positives. Of the people that have been flagged, the large majority actually did do something wrong in their taxes. But we maybe do not know the number of false negatives. So people that were potential issues, but were not flagged. For example, if there is a bias based on race among these people, so it results still in a bias, because if a racialized person does an honest mistake in the taxes, they're more likely to be caught than a non-racialized person. Or similarly, there could be, even if we have a human, some feature that the AI caught up, detected that we do not. Strange example, but potentially. Let's say that the AI from the picture knows to detect if people are from some specific area, and although the human in the loop may still perceive them as white, it may still actually say, oh, from the face I recognize that they are Italian, Romanian, I don't know, and flag them because of that, because of bias in the data, rather than saying, and the human in the loop may be looks fine. The rate of white people versus racialized people in the output seems reasonable, right? So I wanted to understand a bit better how we can avoid that, even with human in the loop, we have these issues. Because I think some people think, oh, as long as it's a human looking at the output and confirming, we're fine. I don't think that's the case.
I have a very short answer. It means diverse annotator crowd. So when you put human in the loop, it's not enough to have, I don't know, 2 people who are your colleagues and who annotated the data. You need to have diverse representative human crowd. And if we are talking about, I don't know, facial recognition, and you know the location where you're going to use that system, so you need to have annotators representing the crowd that, for example, lives in that location. And that's crucial.
Yeah. No, I think it was very interesting to listen to your comments and question, because you gave first a definition of one of the measure of fairness, that of minimizing both the false positives and the false negative. And if you have enough annotated data, you can use that to train the model. So you will be able to go one step further in terms of fairness. And the other definition that you gave extremely well was the automation bias. The human in the loop that, because receives information, they receive information from the system, they will rely on the system output without applying their own critical judgment. And that's a real problem. And it's really important that any human that is interacting with the system, starting from us, is aware that when we start getting a number of very persuasive output from those systems, we tend to rely more and more on them, and we have to control that. We have to be aware, like many of the biases that they characterize our persona.
Yeah, and I think it's also the organizational conditions where the human in the loop is in, like the context, like do you have enough time actually to reflect on the outputs? Do you also have enough skills? How do you do it that you really have like a competent human with enough time and resources to look at the cases? I think that's the main point. If I can bring a little legal example, in Switzerland we have like the data protection law, where if you are subject to a fully automated decision, you are supposed to be informed about it. But it's not the case if there is a human in the loop. If it's just like a partially automated decision, then it's not the case. And there we see that we have all those problems, because how can you say when does it start not being like fully automated? And I think that's really shows also that we need some improvement in the governance regarding those questions.
Mm-hmm. Thank you. Anyone else has a question?
Hi. Thank you very much for moderating and giving us an opportunity to exchange. My question has to do more with governance. So from an epistemology perspective, we usually have to deal with RIB or these type of institutions. And once the output from a prompt is made public and someone has to complain, you can go to court, right? So my question is on the governance of those human in the loop. What would you say would be a good form of control to mitigate, not only because there might be a lack of representation, a lack of diversity, but through the mechanism of the process? Bearing in mind that I know that, for instance, when you talk to a recruiter, and if you want to question the output, there is a legal recourse for you to ask for explainability. So maybe if you can build in terms of would there be process in the future to audit those humans in the loop? Thank you.
I think it's the question about the responsibility on all the value chain of AI, like who is responsible for which part of it. And at the moment the answer is the machine is never responsible. It's always like a human responsibility. It can be some responsibility from the developers, the providers, the one using the system, so that's different in each case. But of course, we need to be still able to understand how decisions are taken, and that's also an important place for like the prevention of discrimination. That people are informed about the automated decision, or like as we said earlier, also the partially automated decision, that we are informed about them, that we have ways also of contesting them, that we have all those rights, so that we can actually also avoid discrimination. And at the same time, we need also like prevention, better prevention, like having like an impact analysis, like audits, like. It's really something we need to do on several levels of the value chain, from the development until the use and of the system. That's we need a holistic approach on that.
Thank you. Anyone else? Yes. Nice one.
Can you hear me?
Yep.
Okay. Hi, thank you very much for your talk. I have a question more in the direction of, well, all your explanations, I think it's very clear for all of us that it's very difficult, even with the best of intentions, to design and to make available fair systems, fair AI systems. So I would like to ask, not from the point of view of the design, but from the point of view of the users, and of the regular user, how can we, or are there tools that we can use to identify the biases on the systems that we are using, or to show to our people that are around us? For example, if I want to talk to my mom and tell her, hey, maybe be careful because of this and this, look at this, at this data about this, about how ChatGPT can maybe invisibilize some groups, or etc., etc. Are there tools available for the general public, and how can we, as maybe a crowd that is a bit more technical or that is involved in the development a lot of these systems, maybe try to go in that direction in which the problem of bias in AI system is more visible to the general public?
That's a very good question.
That's an excellent one, indeed. I think if you want to support the awareness of people using this technology, of the limits of this technology, what you can do at home is what we do in the lab. We test the edge cases. We pass an input, a prompt, and then we change that prompt in a way that is called adversarial. So we are trying to push the system to make a mistake. You could, for example, pass a piece of text with a female name, ask the system to provide a judgment, and then pass on this very same text and change it to a male name and see whether there is a difference. If there is a difference, that will be a very clear demonstration that the system is unreliable. You could do it with generative AI, generating pictures, as we said earlier. But I think already you signaling that those systems aren't perfect is already a very positive step for them to have awareness being raised that they should be critical in the way they interact with those systems, and not because they are technical systems that they deserve their trust. Right? So trust is something that should be earned, and it can be earned by poking the systems with edge cases and see how that system reacts. And if you know the interest of that person, perhaps you can contextualize these little experiments with the interest of that person, so it's more memorable what they will be doing thanks to your intervention and help.
Thank you. Yes, Estelle, please.
Yeah, I would say part of our work at Algorithm Watch is creating awareness on those topics, and we have also a lot of resources on our website on the topic, also just like showing example how discrimination may affect different groups of peoples, etc. So to see the whole diversity also of the topic.
Thank you. Any one last question.
Can you catch? Quick question about algorithms. The TikTok algorithm got a lot of bad press about being addictive and taking to people to sort of unhealthy places. Now TikTok in the US has been sold off largely to Oracle. Are you seeing a change in the algorithm, a divergence between TikTok, the rest of the world, and the US? And if so, is it for better or for worse?
Do you guys have some knowledge on social media and TikTok particularly?
What is clear that the TikTok algorithm is a very clear example of how a learning system adapts very quickly to each of the users. You just browse for a few seconds, a few short videos, and your profile is being built. And probably that's one of the reasons why it becomes a very important tool to understand how to protect the profile of a population living within a certain geographical area. But I'm not aware of any particular changes of the algorithm. This doesn't mean that they haven't been implemented.
Yeah, I mean, we are working actually on social media algorithms, but I don't have, unfortunately, cannot answer your question, specific questions.
Some research to be done for the next roundtable. Thank you for the question, though. Thank you, everyone. Before we close, I just wanted to remind you of another event that takes place this week as part of the annual Week of Action Against Racism. It's on Thursday. It's en français this time, so please join in. You have the QR code, or the team who's organizing it is also here, and welcome you now to continue the discussion, but maybe in a more informal setting at the, on the other side for an apéro. And thank you so much to our panelists. Thank you.